Good morning students, my name is Arun Mishra and we are studying physics. In the last video we had discussed about the chapter physical quantities and measurement. We had discussed about the concept of measurement and the measurement of volume of regular and irregular objects. Today in this video we would be studying about the concept of area and measurement of area of regular shapes and irregular shapes. And we will also introduce the concept of density. So let's discuss about area. Area is the surface occupied by an object. For example, if I talk about the area of the sheet, I mean the surface over here on which we write. So that is the area of this sheet. Similarly, if I talk about the area of this wall, I mean the surface of this wall on which we paint. That is the area of the wall. What is the SI unit of area? SI unit of area is square meter. We also write it as meter square. And how do we define square meter? Square meter is the area of a square whose sides are 1 meter in length. Okay. Now there are other units of areas as well, like hectare and square kilometer. 1 hectare is 10,000 meter square. And if we want to find out 1 kilometer square is how many meter square, we can find it out like this. 1 kilometer we know is 1000 meter. If we square on both the sides, we will get 1 kilometer square is equal to 1000 square meter square. That is 1 kilometer square will become equal to 1000 meter square. So 1 kilometer square is equal to 10 to the power 6 meter square. Okay, so let's now move on to the measurement of area of regular shapes. As we had discussed in the last video as well, regular shapes are those whose dimensions are well defined. Like for example a square or a rectangle, these are regular shapes. To find out the area of regular shapes, you will have to learn their formulae for area. Like area of a square is side square, area of a rectangle is length into breadth, area of a triangle is half base into height, area of a circle is pi r square. So if we know the formula, then say for example we have to find out the area of this triangle, we will need to measure the length of this base and we will need to measure the length of this height, and then if we remember the formula area equal to half base into height, we can find out the area of this triangle. So this way we find out the area of regular shapes. Sometimes we may be required to find out the surface area of 3D object or 3-dimensional objects, like for example the cylinder. We want to find out the surface, this curved surface area. To find that, we will have to find out the perimeter of the base, that is 2 pi r, because it is circle. So circumference of circle 2 pi r times height. So this surface we will get by using the formula 2 pi r into h. So similarly, for a sphere, the surface area of a sphere is equal to 4 pi r square. So for measurement of area of regular shapes, we will need to know and learn the formula for area. Now let's move on to area of irregular lamina. Lamina is any thin sheet. So if we have an irregular shape, for example, look at this leaf. This is an irregular shape. Whose dimensions are not well defined. For such irregular shapes, to find out the area, we will need to use a graph sheet. For example, if I want to find out the area of this leaf. Now, first of all, what is a graph sheet? Graph sheet is a sheet containing square boxes. As you can see, I have drawn with pencil these square boxes. These square boxes have sides 1 centimeter. So the area of this square is 1 centimeter square. If I have to find out the area of this leaf, I will have to place this leaf on this graph sheet, and using a pencil we will have to draw its boundary. Then we will remove this leaf and we will count those boxes which are covered half of the square or more than half of the square. So I have tick marked the boxes which are covered half of the square or more than half of the square. So when I count like that, I get the number of boxes is equal to 9, and one box is equal to 1 centimeter square. So the area of this leaf becomes 9 centimeter square. So you need to count the boxes which are covered half. Like for example, this box is covered half, so it is or little more than half. so it is tick marked, but this box is covered less than half, so it is crossed. So count all the boxes which is covered half or more than half. That counting here it is 9, so that the area of this leaf is equal to 9 centimeter square. So like that we find out the area of irregular lamina. So now let us move on to the next thing, that is density. Density refers to the compactness or how concentrated something is. For example, you look at these two squares. These squares contain dots. This is square A, and here there are few dots. In square B there is more concentration of dots. So the density of dots in square B is more. So density refers to compactness or concentration. The greater the concentration, greater the compactness, greater will be the density. Now it has been observed that for different substances, even if the volume is same, the masses are different. Like for example, I have two glasses over here. They are of volume 200 ml. Do you see 200 ml? This also is 200 ml. In one of the glass, I have filled up water, and the other glass has air. Now, if I measure the mass of water, this much amount of water, and this much amount of air using say electronic balance, then obviously we will find that the mass of the water is more, but the mass of the air is less. Now do you notice that even though the volume is same, but the mass of water is more. Why is that so? Because the density of water is more. Similarly, it has been noticed that even if the mass is same, the volume may be different if the substances are different. For example, here I have a steel piece which is whose mass is 10 gram, and here this is cotton whose mass is 10 gram. Now you notice that the volume of this piece is so very small. It is occupying so less space, but this cotton, even though both are 10 gram only, but this is occupying so much space, so its volume is more. So even though the mass is same 10 gram, but the volume of this is more. Why is that so? Because this one is steel piece is very compact, but the cotton being fluffy is occupying more space. So even though the mass may be same, the volume may be different. And why does that happen? Because the densities are different. This is more dense, this is less dense. So now we can define density. So what is density? Density is the mass per unit volume. That means for 1 unit volume, like for 1 centimeter cube, what is the mass? That gives us the density of the substance. The density of a substance is given by the formula density D is equal to mass by volume, m over volume. And now we know that mass is given has the SI unit kilogram, and volume has the SI unit meter cube. So the SI unit of density will be kilogram divided by meter cube, which we can write it like this, or using index form we can even write like kg times meter to the power minus 3. So either kilogram per meter cube or kg m to the power minus 3. So that will be the SI unit of density. So today in this video we have learned about the concept of area, how to measure area of regular and irregular objects, and we have also learned about the concept of density. But we will be studying more about density in the next video. So you would be required to look at the home assignment which has been posted on your website in a Word file, and you have to write the question answers from your textbook, starting from question 8 onwards related to area and density in your physics notebook. Okay, and also there are some links which you can refer for further studies and further reference. Thank you very much.